All right, hello and welcome back. My name is Cameron Kirk, and this is video 5 on my series of videos on the DE10-Nano projects. And this one is probably going to be another short one this week, but of course it is required for what we're going to be doing next. All of this is, this is going to be a walkthrough on configuring the device tree on this GitHub repository. Link is in the description if you want to attempt this on your own. But I'm just going to be giving a real simple walkthrough on how to get this project working, how to get this guide working, and all this is going to do is just change some settings on our FPGA HPS system to allow them to communicate with each other. And what this is working towards is we're going to be able to write C or C++ programs that actually have header files that we're going to generate that work exactly for our FPGA from embedded Linux. So that's what we're working towards, and that's what we're going to start to see next week. But yeah, I don't expect this video to be too long. So with that said, let's just jump right into it. I hope that you followed along in my previous video or you've attempted it on your own, but this is assuming that you have built embedded Linux from scratch. And we're going to be changing some settings in the device tree. And what we're going to be doing is we're going to make those changes from our development environment or our build environment for embedded Linux. So I still have all of my files here from last time. And actually, I'm going to go ahead and turn off the face cam. So if I make this font size a little bit bigger, give me a second here. Let's go 24 font. Okay, so let's do it clear. And if we take a look, well, let me go back to my home directory. This should be looking familiar. Oh, I did try to install some other stuff since the last video where I showed this, but I still have all of my files and directories from when we made the SD card image. And for this guide, we're going to be going into our Linux SOF FPGA. So let's go into that folder. And then, so here we are, and we are going to be editing this DTSI file. So I like to do that using Vim, but feel free to use an editor of your choice. Vim is good, but also Visual Studio Code works. We're going to go to boot, DTS, SOC, FPGA, .dtsi. Let me pause the recording and double check my mic. Okay, I think we're good. Anyways, yeah, let's keep going. I just wanted to check settings really quickly. So I'm going to push enter on that. Oh, and it brought me in right to the spot. If you page up and page down here, you can see there is a lot of content in this file. Just sort of scroll down until you find our FPGA bridge here. And so here they are, and you can see they are all disabled, just like in the example here. So it says status disabled, status disabled, status disabled. So we're going to enable these, but we're going to do it using a creating a copy of the device tree we're using right now. So we go into that folder and we copy the DTS and make a new DTS. Okay, so let's go ahead and do that. So I'm going to hit escape and then type :Q to back out of here. And then they head into the Arch ARM boot DTS. So cd Arch ARM boot DTS. There's a lot of stuff in here. And they make a copy of SOC FPGA Cyclone 5 DE10-Nano SOC DTS. And they make a copy and call it My Custom DTS. So what I'm going to do is cp SOC FPGA underscore Cyclone 5 underscore DE0 tab. And that auto completed to SOC.DT, just like in the instructions. And then I am going to call this custom Cyclone 5 DE10. We can go ahead and change that name. Nano SOC dot DT. Is that right? DT? No, that should be DTS. I'm going to put an S on that, and let me go all the way back and call that yes. Cool, and I will push enter. All right, so now we're going to edit custom, and we are going to go down to, oh. All right, what are we doing then? Copy and paste the lines right at the end of the file. Okay, so I'll click this button, and then we are going to go all the way to the bottom. And I am going to type an I for insert, and right click to paste, and then push escape, :W to write or save those changes. Oh, I clicked on something. Whoops, go back. Okay, so we have that copied in. These values will overwrite values in the included file. Okay. So now what we need to do is generate the device tree binary. So we're going to go into the parent folder. So I'm going to do a :WQ. I'm going to do a CD tilde / Linux. And then we're going to run make. And if we can try running this. And if it doesn't work, there's going to be some things we need to set up to get our cross compile. Okay, it did not like that. No rule. Oh, that's because I did not call mine my custom DTB. DTB? Shouldn't it be DTS? Custom Cyclone 5 DE10 Nano SOC DTB. Well, we'll try with that first, but I think it should be DTS. But let's see what happens. DTB. Enter. Okay. I'm hoping that's a good sign. DTB. Okay, and then I skipped the get stuff, which is fine, because we made a copy with our changes. Okay, so now what we're going to do is we are going to SCP this over to our DE10-Nano. So let's do this. Let's go to the tabletop. That's not what I meant to click. All right, and then let's connect our USB cable to the UART USB. And we'll connect the power to the board. We'll come back over to the desktop and open PuTTY. Switch to serial mode. We're going to open Device Manager. COM3. Sometimes it does change. 115200. Okay, and it looks like it's dead, but if I push enter, we're at our login. So I'm going to type root. Password is root. I'm going to issue an ifconfig. And this is our IP address right here. So I'm going to hit Control-Shift-C to copy that. And SCP is working on here. Now the real question is, oh, it's located in there. Well, just to make sure, if I do an ls arch arm boot DTS, where is it? DTS Enter. Is there a custom in here? Oh my gosh. Well, I made it this far. I may as well commit DTS and DTB. And we want the DTB. Okay, yeah, so that worked. All right. So we're going to SCP the file inside Arch, ARM, boot, DTS, custom, DTB, and we're sending that to user root at, right click for the paste, this IP address at location home directory. Enter. Yes. Password is root. And there it goes. So now when I come over to PuTTY, if I do an ls, there is our DTB. So far, so good. So now we're going to mount our device tree and replace it with the new device tree. Appearance. Okay. So we already have this FAT folder. If I do an ls on this folder, there's nothing in it, but we have our mounting point. And what we can do is we can call a mount on dev mmc block 0 p1, and we're going to use mounting point FAT. Enter. So now when we do an ls on FAT, there's stuff in there. Okay. So now we're going to make a backup. Right. And it looks like we're keeping it in that folder. So we're going to copy from FAT the SOF FPGA, this device tree binary. I'm assuming the B stands for binary. And we are going to send it to the same directory, SOC FPGA, and then we're going to call it backup. I'll just spell out backup. Enter. And then we are going to replace the one with this name with the contents of our new DTB. So we're going to do a CP of custom cyclone. There it is. And we're sending it to FAT SOC FPGA .dtb. We're overwriting. So push enter, and we just overwrote that. We're going to umount or unmount FAT. So now when we ls FAT, there's nothing in it, and we're going to issue a reboot. And if everything goes smoothly, we should complete the reboot. And it shows us how to check if we did this correctly by issuing that command. All right, so login is root, password is root. And we're going to do a cat. The root folder sys class FPGA bridge splat state enabled. You should see that they're all enabled. This means we are now ready to flash our design and run a program into user space. So like I said, this is a pretty short video, pretty simple stuff. We are doing all of the groundwork to start doing some really cool projects in the future. Obviously, I want to get through the rest of the walkthroughs that are shown on this GitHub. And then what I have in store next is, I think I might have gotten into this once before, but just to give you a sneak peek, the only thing I don't like about this DE10 Nano board is I/O. You know, you got 8 LEDs, 4 switches, 2 push buttons. There's plenty of GPIO, but what I wanted to do for my next video was show you how to make an ALU, a arithmetic logic unit, in Verilog. But the only problem is we don't have enough seven segment displays or any sort of displays that show us what is in our registers and what is going through the ALU, what are our operands and what is our output. There's no way to view those numbers. So the current plan is to get through the rest of these walkthroughs, complete what's on the GitHub, and then hopefully by that point we should be able to write software from the ARM processor that will allow us to send operands to our custom ALU and get the result back and print out the result all from Linux. So that's the game plan. So we're going to use Linux as our input-output. Anyways, I hope you enjoyed that. Thanks for watching, and I'll see you next time. Take care. Bye-bye.